Hello everyone and welcome. Today we're going to be talking about percentage composition. Now this corresponds to section 6.6 from our textbooks. So what is percentage composition? Now before we get into it, what I'm going to do is I'm going to give us a quick little example to kind of get us started. Okay, so let's say we had a test. Okay, now this test had multiple choice. It had, let's say, matching, and it had short answers. Okay, so there's 3 sections to this test. Now, let's say there were 10 multiple choice questions. Let's say there were 20 matching questions. And let's say there were 5 short answer, not questions, sorry, these are how many marks we had. Okay, so 10 marks were multiple choice, 20 were matching, short answers we had 5. Okay, so what percentage of this test was multiple choice? Okay, so I want you to think about that. What percentage of this test would be multiple choice? Now, in order for us to do this type of calculation, we need to figure out what is the total amount of marks in this test. Okay, so if we add this up, we have 10 plus 20 plus 5. So 10 plus 20 is 30 plus 5. So this test was out of 35. So how can we figure out what percentage of this test is multiple choice? Well, what we're going to do is we're going to take those 10 marks for multiple choice and divide it by the total. Okay, so that will give us a decimal answer. Okay, so I'm going to take 2 decimals because once again, that's kind of the standard. So we would get 0.29. So what percentage of this test was multiple choice questions? Well, to find a percentage, we need to multiply by 100. So we would get, I'm going to do it underneath here, 29% of this test, roughly, was multiple choice question. What about short answer? What percentage of this test was short answer questions? Well, we would take 5 and we would divide it by 35 because once again, 5 marks on the test is short answers out of a possible 35. So if we do that calculation here, we get, once again, I'm going to round, I got about 0.14, but that's not a percentage, that's a decimal. So we need to multiply by 100 to give us a percentage, and it would give us 14%. Now what about this last one, matching? Well, we would take 20, divide that by 35. Okay, so it would give me about 0.57. I'm jumping the gun there. And we'd multiply this by 100. And it would give us 57%. So in this test, multiple choice was about 29% of it. Matching, 57%. Short answer was about 14%. In total, if you add these all up, they should add up to 100. Now, the reason why they should add up to 100 is because if you add 10, 20, and 5, that should add up to 35. So all the total values are accounted for. Okay, so that's essentially what we're going to be doing with percent composition. We're going to try and figure out in a molecule, let's say we had something like C10H, I don't know, 20O4, what percentage of this molecule is carbon? Okay, so what is the percent of carbon? Question mark. What's the percent of hydrogen? What's the percentage of oxygen? Okay, now it's not as easy as just adding up 10, 20, and 4. Okay, there's more steps to it, but that's the idea. Okay, so that's kind of what percent composition is all about. All right, so let's go back to our lesson here. So percent composition, what is it? Here's our formal definition, so make sure you know that. It's the percentage by mass of each element in the compound. Okay, so we're going to figure out how much percent of each element is in a compound. So that's exactly what we're doing here. What percent of carbon in this molecule? What percent of hydrogen in this molecule? what percentage of oxygen in this molecule here. Now, we can determine this in a lab using something called a mass spectrometer. Now, they talk more about this in 6.6, so I recommend you reading it after and going more into depth. But essentially, what a mass spectrometer is, it's a big device, and what happens is, we don't have it in high school, but in post-secondary, most universities will have it there, as well as colleges. And what you do is, typically they'll give this to you in a lab setting. So if you have to do a lab in your class, typically what's going to happen is they're going to give you a random compound. Okay, you won't know what this compound is. Most times it's solid. So they'll give you this compound and they'll say, you need to figure out what percent or what type of compound you have. Okay, so how you do this, well, you're going to take that compound, that solid compound, and you're going to put it in this machine. And once again, this machine is called a mass spectrometer. So you put that compound in here. Typically, there's like a hatch. You open it up, put it in, close it. Then what you're going to do is you're going to burn it off. You're going to heat it, evaporate it. And while that's happening, oxygen is going to be flowing in, because what's going to happen is after you evaporate it, we want all the compound, all that evaporated compound to go through the machine. So the oxygen pushes it through. Now, once you evaporate it all, it's going to go through one chamber. Okay, now the first chamber takes out water. Then you're going to go through the second chamber. And in the second chamber, it takes out carbon dioxide. Now you might be asking, why would we get rid of water and why would we get rid of carbon dioxide? Well, if you remember your combustion reactions, a combustion reactions always makes water and carbon dioxide. Those are two of the products. So that's essentially what we're doing here, is we're combusting this compound. We're evaporating it, we're burning it. Now, in grade 11, we only talk about hydrocarbons. Most likely in your lab in university, it's not going to be just hydrocarbons. You're going to have some other compounds in there. You might have oxygens. You may have sulfurs, phosphoruses, right? So what this machine will do, it's going to get rid of the water. It's going to get rid of the carbon dioxide. And whatever is left over at the end of this machine, okay, that's what it's going to read. And what it's going to tell you, it's going to say this. It's going to say 20% of your compound is oxygen. It's going to say 40% is hydrogen. It's going to say another 40% is carbon, whatever the case may be. So that's what this machine's going to tell you. It's going to tell you what percentage that compound is made up of. And then once again, why would we need to know this? Well, we'll see a little bit later on. But that's what a mass spectrometer does. And once again, if you read section 6.6, it'll talk about it in more depth. But that's essentially what it does. Okay, now once again, before we start getting into our questions and stuff like that, there's still a couple laws that we need to understand. The law here that we're trying to understand is something called the law of definite proportions. Now, what this is saying, okay, is that if you had one molecule of water, or if you had an ocean full of water, every single water molecule is always going to be H2O. Okay? So once again, if I had one molecule of water, if I had 50 molecules of water, if I had 1,000,000 molecules of water, every single water molecule is going to be H2O. For every one oxygen, there are going to be 2 hydrogens. And that is called a proportion, that's called a ratio, and that's why we call this the law of definite proportions. And what it says is that elements in a compound are always present in the same proportion, no matter what your mass is. So if I had 1 gram of water, or if I had 1,000,000 grams of water, it's going to be the exact same ratio. And that's all that this is showing here. It's just showing a bottle of water, 2 hydrogens, 1 oxygen. Same thing if you had like an endless stream, tap water. Okay, now once again, you might be thinking tap water has compounds in it or other elements like sulfur and chlorines and stuff. Once again, let's just pretend it's just pure H2O. Okay, so once again, we're just talking about pure H2O. All right, so once again, make sure you understand what law of definite proportions is saying. It is quite simple in that definition. Now, we are going to be using this formula here when completing our percent composition questions. Now, you'll notice on your formula sheet that this is not given as a formula. Okay, now the reason why this isn't given as a formula is because this is a standard percentage formula. And what I mean by that is if I asked you to calculate the percentage you got on a test, I don't need to give you a formula for that. You all know, right? If you had a test and it was out of 30 marks and you got 27 out of it, right? How would you come up with that ratio? How would you come up with that percentage? Well, you would divide these two, get your 0.9. And if I was asking you what percentage you got, you would multiply by 100 and you would get 90%. So that's essentially what this formula is. Okay, and once again, that's what we were using over here, right? If I asked you what was the percentage of multiple choice questions, you can come up with 10 out of 35, multiply that number by 100. Same thing with all of these here. So that's why this isn't given on a test for a formula. Okay, so once again, as of right now, it might not make sense to you, but let's do a couple questions and it will make sense. All right, so for percent composition, there are two types of questions you will get. Okay, the first type, which is less common, is when you're given masses. The one that is more common, the one that we're going to see more often, is when you're given a formula. Okay, so there's two types of questions that we're going to be looking at. So let's do the first one here. This one's a little bit easier. So, 11.5 gram sample of a liquid. Okay, it contains 6 grams of carbon. It contains 1.51 grams of hydrogen, and the remaining mass is oxygen. Determine the percent composition of this compound. So, the first thing that we're going to do is we're going to figure out how much weight do we have of carbon, hydrogen, and oxygen. We're going to need that. Okay, so the first thing we're going to do, let's go ahead and write our total mass. So our total mass of this compound is 11.5 grams. Okay, so your teacher gave you 11.5 grams of this random liquid. Okay, and your teacher said that, well, the mass of carbon in this is 6 grams. The mass of hydrogen is 1.51 grams. Now, the remaining mass of oxygen, well, we don't know that, so we need to figure that out. Okay, so how we would do this mathematically, okay, and I'm going to maybe do it at the top here, as you can see. Okay, we're going to have 11.5 is equal to 6.00 plus 1.51 plus x. Okay, so what this is saying is that the total is equal to 6 plus that one and plus a third one. So we're trying to find out what is this third one here. So how we do this mathematically is we're going to move all the numbers onto one side. Okay, and when you move it to the other side, it becomes from positive to negative. So we would get 11.5, subtract 6.00, subtract 1.51. Whatever that leftover is, that's what our mass of oxygen could be. Now, you may be able to do this in your head, and that is fine. Okay, I don't need you to show me this step. But once again, if you did this in your head and you got the wrong number, me as a teacher, I'm not going to know how you got this number, so I mark it wrong. If you showed me your work and then I can see, the person just made a little mistake, well, at least you could get part mark. So always show as much work as you can. So anyways, let's go ahead and calculate this. Okay, so I got 3.99 grams left over. And that's how much oxygen I would have. Okay, so that is our first part. Now, our next part, we're going to figure out what percent of carbon do we have in this compound. So this is going to be my first part over here. Now, in order to do this, we're going to use this formula right here. We're going to take the mass of the element and divide it by the total mass of the compound. Okay, so I'm going to write it out for the first time. Mass of element, and we're going to divide it by the mass of compound. Okay, and we're going to have to multiply by 100. Okay, hopefully you can see that there. Okay, so this line is just to split up because we're going to do carbon, we're going to do the other ones as well. Okay, so let's go ahead and let's put our numbers in. So the mass of carbon was 6 grams. So I'm going to put 6 grams at the top, and I'm dividing it by the total, which is 11.5 grams. And then I need to just multiply by 100 to get a percentage. Now, as you'll notice, once again, this is mathematical based. So we need to make sure we're canceling out units. So grams and grams will cancel out, and we'll be left with the percent. So if we do 6.00 and we divide it by the 11.5, you'd get 0.52. We're going to multiply by 100% and take 2 decimals, and I got 52.17%. Okay, so once again, I'm taking the mass of the one part and I'm dividing it by the total. Just like we did over here, right? We took the marks out of one part and divided by the total and multiplied it by 100%. Okay, so let's try one other one, and then I'll get you to try the third one by yourself. So we have percent of hydrogen now. Okay, so I'm not going to write the formula out again, just for spaced reasons. Okay, but we're going to have mass of the element, which is 1.51 grams, and I'm dividing it by the mass of the compound, which is 11.5 grams, and I'm multiplying by 100. Okay, so when I did this here, I got 13.13%. Once again, grams are canceling each other out. Okay, so that's what we get there. So what I want you to do, pause the video now, okay, and try for our last one, our percent of oxygen. Okay, so do that now, please. Okay, so our last one here, we had 3.99 grams divided by our total, which is 11.5 grams. And we're going to multiply it by 100 here. Now this is going to give us 34.695. Okay, so if we're rounding to 2 decimals, okay, so I'm going to write this out here. We had 34.695, but if we're rounding to 2 decimals, we're going to get 34.70%. Okay, so that's our last number here. This is this one, 13.13 and 52.17. Now, a quick way to check your answer. Okay, I'm going to put check here. Add up these percentages. They should add up to 100. Okay, so I'm going to do that right now. I'm going to put 52.17 plus 13.13 plus 34.70. And if I add it up, I get 100% right on the dot. And that's what we should be getting. Now, there will be times where you could get 99.99 or 100.01. Okay, now the reason why that happens is if 2 things got rounded up or 2 things got rounded down. Okay, so typically we want things to cancel each other out, but you may see 100.01 or 99.99. And if you get those numbers, don't be alarmed. Okay, if you get anything lower or higher than that, you may have done some rounding errors along your way. Okay, so anyways, that's the first one. This one is typically the easier one. All right, so the next one is this one here. Okay, so we're going to determine the percent composition for glucose. Now, I don't expect you to know what glucose is. Glucose is a type of sugar, essentially. Okay, but I would give you the formula for something like this. Okay, now, one thing I want you to understand. This one you're given masses. This one you're given a compound. So there's going to be a little bit of a difference between the two. Okay, so for this one here, I'm actually going to do it on a separate sheet of paper because I'm just going to need a little bit more room than what I have here. Okay, so what I do need though is I need glucose, C6H12O6, okay? So I'm looking for the percent composition of this compound here. Now, in the last question, we worked with masses. I don't have any numbers here. Can you think of something else I could use instead of masses? Well, I hope you said molar mass, because that is correct. We can find the molar mass of this compound. So that's what we're going to do. Okay, so the first thing we need is just like the last question, we need the total. Now, instead of total mass, we need total molar mass. Okay, now once again, your molar mass, this is where you use your periodic table. So you would add up 6 carbons, 12 hydrogens, 6 oxygens all together, and our units would be grams per mole. Okay, last time we were working with grams, which is just mass. This time we're working with grams per mole. Okay, so let's go ahead and let's do that here. Okay, so 6 carbons, carbon is 12.01. Hydrogen is 1.01 and oxygen is 16.00. So if we do that calculation, I got 180.18 grams per mole. Okay, now once again, at any time, pause the video, try the calculation. Make sure you can get the same number as I do, okay? Because once again, that is going to tell you if you get the answer right or wrong. So now we have the total mass. However, we are going to need the molar mass of carbon. We're going to need the molar mass of hydrogen. And we're going to need the molar mass of oxygen. And once we get that, then we can do what we did last time. Now, one big thing that you need to understand is that we need to take the mass of 6 carbons. Reason why? We know the total. We need to figure out every single part. So it's not just the molar mass of 1 carbon, it's 6. So I'm going to put a bracket, I'm going to put 6 carbons here. Okay, we need 12 hydrogens. We need 6 oxygens here. Okay, so what I'm going to get you to do, just pause the video, come up with these molar masses, and when you're done and you get these molar masses, you know you'll be correct if you add them all up and get this exact same number here. Okay, because all these parts should add up to the total. Okay, so do that now and then resume it when you are done. Okay, so after doing this, I got 72.06 grams per mole for carbon. I got 12.12 grams per mole for my hydrogen. And lastly, I got 96 grams per mole for my hydrogen. And once again, if you add up these 3, they should equal exactly your total mass. Okay, now that we have all these numbers, now we can go ahead and we can figure out our percent compositions. Okay, so the first one, we're going to find the percent of carbon. So just like the last question, I'll write out the formula and then we'll go ahead and we'll do it together. Now, the formula says mass of element. Are we using the mass right now? No, we're using molar masses. So we're going to just change this up slightly. So we're going to put molar mass of element divided by the molar mass of compound. Once again, to get a percentage, we need to multiply by 100. So let's go ahead and let's do that here. So our molar mass of our element of carbon was 72.06 grams per mole. And we're going to divide it by our total, which is our compound. So that's 180.18 grams per mole. Okay, once again, always include your units of measurement. And then we're going to multiply it by 100. So after this, once again, grams per mole and grams per mole are going to cancel out. That's why we don't have a unit of measurement. Okay, we only have percentage, which isn't technically a unit of measurement. So when we do this here, I got 39.99%. Okay, I'm just going to check this over. And that's exactly what I got here. Okay, 39.99, and it goes like 333, so we keep it rounding down. So next, percent of hydrogen. Okay, so this time I'm not going to put the formula, okay, because once again, it's just right there. So we're going to have 12.12 grams per mole, because that's the mass of my element, and I'm going to divide it by the total and multiply this by 100. Okay, I'm going to take 2 decimals after this, and what I got 6.73%. Okay, now for you, I want you guys to once again pause the video, try for oxygen, okay? And when you're done, resume it and see if you got it right. All right, so hopefully you pause this video. So 96, okay, now once again, one error that I did, we should have 96.00, okay? We want to keep everything consistent with our decimals because that's what we had. So 96.00 grams per mole. And we're going to divide it by 180.18 grams per mole. And I'm going to squeeze this in here times 100. So doing so, we get 53.28%. Now, once again, whenever you do something like this, you always want to check your work. Okay, and you check, a simple check is just adding these up, and it should be 100. And I already checked my work before. It is 100% on the dot. So we know that this would be correct. And maybe you can't see that. Okay, oh, sorry about that. Okay, it should say check 100%. Okay, so with that being said, that concludes percent composition. And once again, those are the 2 types of questions you'll get. One is where you're given masses, or the other one, more common one, you're given a compound. Okay, so you could get something like sodium phosphide or calcium carbonate or any compound like that, and you would have to do it this way here. Okay, all right, thank you very much for watching and have a great day.